Let's solve this system of inequalities by graphing. Now, we have two inequalities already in y equals mx plus b form, or in our case, y is less than, y is greater than mx plus b form. Either way, slope-intercept. So let's graph this guy first. I have a slope of 4, or 4 over 1, and I have a y-intercept of negative 3. So let's go to negative 3, put a dot there, negative 3 on the y-axis, and go up 1, 2, 3, 4, right 1, up 1, 2, 3, 4, right 1. Okay? Easy peasy. Now, in order to graph this, there's two added things that we have to remember. Okay, first things first, if I were to use this line to graph it, this line isn't good enough. That's greater than, which means my line is supposed to be dashed. So let's make it dashed and then connect our dots. Now again, not good enough, because by doing this, we also notice that this is a greater than symbol, so we are to shade above the region. So let me get a nice yellow color and shade above the region, which appears to be over here. Okay, now when you have a steep line like we do, always view it as you either have a mountain, which is above the mountain, or below the mountain, and this is above the mountain when we graph it. So here is my shaded region above the mountain, where the dashed line is the mountain. Now at this very moment, solutions to this top equation are going to live in this shaded region. But I don't care about just the one equation, I care about both. Now let's take a look at the other equation and how that affects everything that we've done. So let's graph the other equation in blue. Similar idea, we have a slope of negative 2, so negative 2 over 1. And then I have a y-intercept of 3. So we go to 3, put a dot there, and we graph negative 2 over 1, which is up 2, left 1, or down 2, right 1. Now we can see where these guys intersect, but keep going, down 2, right 1, down 2, right 1, down 2, right 1. This is a solid line because it's greater than or equal to. So this line right here is fine, just fine. So let's graph like so. Now, this is greater than or equal to, which means we need to shade above this solid line. So here we go, here we go, here we go. And although it's not perfect, what we see is the area that was untouched by the yellow is blue. But when the yellow and the blue meet, we have this green feasible region right here, which I'm going to label R. Now my solution is going to be any point that lives in that feasible region, including anything on a solid line but not on a dashed line. So the point 1, 2, for example, right there, lives in the green, which means 1, 2 satisfies both of these inequalities. Oh, that was a close one. Both of these inequalities. So that, boys and girls, is how you solve these system of inequalities by graphing. You're looking for where both shadings meet. Slim shading. So the rapper, remember him? M&M's? Thanks for watching.